None.
Okay. So you want STM, there will be STM and talking face detection. Okay. So I'm Nam from EDF and I will present the EUMSSI team. Yeah, they're the two supervisors. Okay. So the overview of our method is very simple. We do clustering on the speakers, we do clustering on the face. Similar face would have similar names, similar speech should have similar names, and we just propagate the name independently on the face cluster and on the speak clusters. So the task is very simple, get the name and get the right clusters. So for the names, the video, OCI and NEI is the important things the other teams have mentioned, and we were the one who gave the baseline for them, and yeah, we're responsible for this. So our method based on text region detection, and then we do clustering to binarize the text, and then use Tesseract to recognize the text from that, and merge different strategies to get the final result. So we emphasize on getting as much text as possible from the same image. And then the name entity is recognized using MIT information extractor with heuristics, so that we remove some very, some recurrent error that we often see in the videos. And for face diarization, from the shots, we use face detection with deformable path-based model. We have a library to do this in almost real time. And then face tracking, we formulate star tracking by detection. We create the link between the detections as a graph and do optimization on that. And for face clustering, we do hierarchical clustering with self-matching and eye vector on the faces. For talking face detection, so this more interesting part, from a face track, we detect the mouth regions and collect the motions within the mouth region in 3 times 5 bins, and then concatenate 5 frames together. So this is one block, and do PSA on one block to reduce the dimension. So now we have a sequence of blocks, and we use OSTM, and we train an OSTM unsupervisedly, like a temporal autoencoder. So we take one step and we try to predict the next step with a bottleneck layer to compress the features. So after that, we just do the mean pooling over the hidden layers and put a linear classifier. So from the classifier, we have a confidence score of a person is speaking or not speaking. And we have a data set publicly available for doing talking face and talking detection. And speaker diarization, this is also the baseline that were given to every participant based on LIUM open libraries. So from this we have all the clusters of who is speaking. So now the name will be propagated to on the face cluster and on the speaker clusters. And the problem now is just how to fuse them together. So from the experiment we did, we see that in this case face are more reliable than the speakers, because we have 4 different languages in our data set, and a lot of cases when they are dubbing over the real language. So if the face and the speaker agree with each other, we will rank the results the highest based on the talking score. Otherwise, we will rank face naming higher than speaker naming. So this is an illustration. So let's say from shot number 1, person red appears and speaks. So that will be ranked highest, like 2 plus the talking score. Meanwhile, the person number 1 only speaking, so the rank for person number 1 will be only 1. And the similar things do on shot 2, they appear and speak, so they have very high score. And for the yellow person, he only appears, but he still ranks higher than the one who only speaks, because we trust the face modality more than the speaker modality. So when the query is asked to give back on the shot with the green person, then shot number 2 will be given first, and then shot number 4 and 1 and 3. So speakers and face naming agree, and then face naming and then speaker namings. That's how we trust each modality in this case. So for the submission, we have 5 submissions. So the first one, submission number 1 and number 2, we keep the same face diarization system. We just switch the name entity and OCR recognition. So you can observe, just look at the map, and you can see just by switching the set of names, we already double the score. So the first lesson we learned from this is that the name is very important, like the other teams already mentioned. So if you miss one name, because the map is averaged over all the people's names, so if you miss one name, it will penalize a lot more than one wrong name. So that's why just get as many names as possible. So I think that's one disadvantage of using map. And the second thing is we now have an explicit model to do talking phase detection. So when we add the model to explicitly detect the talking phase, we can improve the results. And so the first 3 submissions, we use only the visual modality. For the 4th submission, we merge the face modality with the speaker modality with preferential ranking, if they agree or not agree. So from this, we see an improvement, but not that much. So this is a different thing from the data set from last year. Last year, we just used speaker diarization and everything is nice. But this year, because of the languages, because of dubbing and reaction, then it's different. And finally, so the final submission, we merge our result with the baseline result, and we see a big jump again. This shows, again, in this task, recon is much more important than try to do it precisely. And also show that there's a lot of room for improvement, and we already have some talk on collaboration in the future. Okay, so that's pretty much it. Thank you for your attention.